Welcome to this lesson on character arrays. My name is Donna Martin and I'll be your instructor. In this particular chapter, we're going to talk about character arrays. Now I know we've addressed arrays in the past. We mostly did floating point arrays and arrays of integers, but I want to specifically talk about character arrays, and that'll prep us for the next module, which talks about character strings. We're going to talk about how you create them, declare them. You already know pretty much how to do that, but we're also going to talk about initializing character arrays. There's a shortcut way of doing that. And then we're going to talk about how to print character arrays. All right, so you have seen arrays in the past. We've done integers and floats and some things along those lines. We haven't specifically done a character array though, so that's what we're going to talk about for the next couple of slides. Declaration is the same as declaring an int or float array, where you have a variable name and then you have a index telling how many of them you want, and then you tell it what type it is. So teacher is an array of 8 positions, something like that. Just like every other array, it starts at teacher of 0 and it goes through teacher of 7 because subscripts start at 0 in C. So we would get something like this, an uninitialized character array. Now here is an initialization of a character array. Same 8 that we had before, and the way that we indicate characters in C is we have the character with a tick mark around it. So the character M is represented this way. Okay, so what I'm doing here, I have 1, 2, 3, 4, 5, 6, 7, 8 positions. So I'm initializing this character array to say MR space SMITH. Now, we had seen earlier that when I do arrays, I normally do them vertically. But I had mentioned at that time that once we got to character arrays, I would normally do them horizontally. There's really no difference. The main reason I do it this way is because typically if we have a character array, we have a name or we have a phrase or something in it. So it's just much easier to read for me if I go left to right instead of up down. Now one thing I should indicate here, because I'm not sure it's perfectly clear, when I have these 2 tick marks here, there is actually a space between them. So this is that blank character. So I should have spaced these just a little bit further apart to indicate that there is a blank in the 3rd position in teacher of 2. All right, so I want to talk about, let me back up for just a minute, what is really going on here? What are these characters, this M thing that I did up here with the capital M? I mean, what's really happening inside this teacher array? So we want to talk about the ASCII chart. And basically, the way that this works when we're going through is these characters, or these numbers that you see over here in these columns, are what is actually representing the characters. Now, these are all special characters like backspaces and ringing the bell. So let's move over into these columns here. So in other words, if I'm looking for Mr. Smith, to show you what's really being stored in that memory location, what I would do is go look up the numbers, the characters. Here's a capital M. Well, capital M is represented by the decimal number 77, or hexadecimal 4D, or octal 115. These are all the same numbers. So that is the actual value that's stored in the memory location, the value 77. We represent it as a capital M because we're actually going to be printing it with the %C character code of printf. So it would take the number that's stored in there and print it as a character, the corresponding character that's indicated by this chart. So basically that's what you do, is you just go through and you look up, there's the R of Mr., and that's number 114, and a blank is over here, probably, oh, here's the space. That's number 32, and then we have the capital S of Smith, which is here. That's number 83, and so on and so on and so forth. So those are the actual values that are stored in that character array. We represent them as character string constants because, we represent them as characters because it's easier for us than trying to remember that 77 is a capital M and 114 is a little r and a blank is 32 and so on and so forth. But that's what the computer sees, and then it's just output it in a way that we understand it as characters. All right, one more thing I want to say about these character arrays. It's very tedious when I'm initializing things to have to drag those little tick marks around. So in the notes, when we're dealing with character arrays, I'm not going to use the tick marks. They're going to be implied, so that when you see something like here, just assume that this is the character M and the character R and the character blank and so on, so that I don't have to go through and type those tick marks every single time. This is actually the more accurate representation, but in the notes we're going to be doing this just because it just makes it easier to read too. All right, so let's go back to our initialization. This is just pointing out, as we have before, that any time that you're initializing an array, if you initialize all of the elements of the array, you can let the compiler count for you. So if there aren't any extra ones here, if it's just Mr. Blank Smith, which is 8 characters, you can let it count for you, just like any other array. And you still get the same array that gets initialized for you. And just like any other array, if you only initialize a subset of them, like here, we have created 10 of them, but we only initialize the same 8 that we had before. That means there's 2 more spaces out here that we didn't initialize, 2 memory locations that we didn't initialize. And if you remember, we said that when you initialize an array, if you set up fewer, if you initialize fewer than there are elements in the array, it clears out the rest of them for you. So it's going to give you zeros in those memory locations. And the same is true in a character array. If we were to go back and look at the ASCII chart one more time, and we look at what a 0 is, that's the very first entry in the ASCII chart, that's a null character. So a lot of times when we're dealing with characters, we represent, oops, I went the wrong way. We represent them as a null with this \0. That indicates a null. If you wanted to just put a 0 in there, that's fine. It is literally the same thing. But since these are actually characters, you know, tick H, tick, and so on, we represent the null character with the \0. All right, so again, the main point here is when you're initializing a character array, if you have fewer values on the right than you've allocated on the left, it'll zero them out for you. In order to translate it from the number 77 to the capital M, printf has a specific format code to do that, and that's the %C. If you wanted to, you could print our character array with a %D, and you'd actually see the ASCII values. That's not what I want because I don't remember them and I don't want to have to go look them up. So we're going to use printf with a %C for our character array characters. So here's a print statement printing out the teacher's name. And I did the print statement in a for loop because that was much easier than trying to do teacher of 0, teacher of 1, teacher of 2, teacher of 3, all the way through teacher of 7. But remembering that we initialized teacher to 8, we're going back to teacher of 8 being MR space SMITH. We're not going to do the one that had extra characters. All right, so we've already initialized teacher on the previous slide. Now we're printing the teacher's name is and this ending space right here because we're going to enter the for loop. All the for loop is going to do here is print off just the character, all 8 of them. So teacher of 0 gets printed the capital M, teacher of 1 the little r, teacher of 2 the little space, teacher of 3 the capital S, and so on and so on and so on. So we print the teacher's name is space the capital M and then all the characters of the teacher's name, and then when we're all done we print the new line. So this really only prints one output line. The teacher's name is Mr. Smith and then the new line because you get to control when new lines occur. All right, so that's great. There's another way to do this though. There's also a putChar function. It's similar to getChar, but as you can imagine, it does the opposite. So getChar went and got a character from the user, and we stored it in a variable. putChar takes the character you give it and outputs it to the screen or to wherever if you redirected your standard out, but it goes to standard out. So here's the same thing that we did before. We're going to output the teacher's name. And so we're going to use the print statement just like we did before. No change there. I'm going to print the teacher's name is in a space, still using a printf. However, I'm going to modify my for loop and I'm going to use a putChar instead of the printf %C. So I'm going to go through and I'll still go through the for loop 8 times, but I'll be printing teacher of 0, teacher of 1, teacher of 2, just like before. But this time I'm going to be passing that character into putchar rather than passing it into printf%c. Now it turns out that that's much more efficient. Putchar doesn't have much overhead at all. It's a very fast, efficient little function, mostly because it doesn't do much. All it does is accept a single character and output it to standard out. That doesn't take a lot of overhead for it to be able to do that. Whereas printf can do a lot more. It takes a character string and a bunch of characters and it outputs those until it hits a percent code. When it sees the percent code, it goes and gets the next variable on the list and gets its value and prints it out in whatever way you told it to. So there's a lot more going on than just a simple little putchar statement. So putchar is much more efficient. If all you're outputting is characters, if all you're doing is a printf%c, then putchar may really be a better option for you. All right, so after we've printed out Mr. Space Smith, then I need to do the new line. So I'm not going to do that with the print statement that I did before with the printf. I'm going to do it with a putchar as well because a new line is actually just a single character. I don't need to call printf with the quote, new line quote. I can just call putchar with a tick, new line tick. Now let's talk for a minute what that difference is. We see up here in the print statement that it's using these double quotes. That's because it has a bunch of characters that it's printing. We'll see in the next module that this is a character string and we'll learn all about character strings. But basically you use the double quotes because there are multiple characters here. We saw when we initialized a character array that character constants are put in the single tick marks. Putchar is expecting only a single character. So you either send it a character variable like teacher of 0, or you send it a character constant, and character constants are denoted with the tick marks, not the quotes. So previously when we called printf, it's expecting a format string, so it's expecting the double quotes. Putchar is expecting a single character, so you need to use the single tick marks if you're going to be giving it a character constant like the new line. Now, as far as you're concerned, you get the same output, the same answer, and on most modern machines, you're not going to see some big difference between using the previous version and this version. However, I just want you to understand that putchar is there and available for you, very fast, very efficient, and it works really well. Just make sure that you're using it correctly and you're sending it a single character so that it can output that to standard out. Don't get confused between your double quotes and your single tick marks when you're dealing with your character strings, which is what you're dealing with the double quotes, multiple characters, or when you're dealing with one single character, which you use the single tick marks for. The other thing that you can do if you really want to with the putchar, because remember, putchar is taking in a character and outputting it to standard out. If you wanted to, you could actually go out to your ASCII chart and find the number and then stick that number in there, and then it would translate it to the appropriate code and print the appropriate letter. Normally we're not going to do that though. We're just going to send in the character constant, or we're going to send in the variable that has a character in it to putchar. All right, so that kind of lays the groundwork for the character arrays that we've been kind of dealing with up to now. It's going to prepare us to move on to the next module where we're going to talk about character strings and what they are and how they're related to character arrays. Thank you for joining me for this module, and I hope you'll join me for the next ones.